Hi everyone, a very good afternoon. Thank you so much for joining me in this webinar. So basically today I'm going to basically talk on basics of Cosmosil HPLC columns. So basically what I'm going to go through is I will do an introduction, basic and some principle as well as a workflow of HPLC, and then also introduce a bit of Cosmosil products, and then a few problems and troubleshooting in HPLC, as well as how to maintain the column that you have purchased for your HPLC equipment. And finally, I will end with some support. So let's start with our introduction. What is actually chromatography? So chromatography is actually a process that separates chemical compounds from one another. So basically it's a driving force for chemical equilibrium that results when two compounds are distributed between two phases. So when it comes to chromatography, so if you see on my right, you are going to see two types of chromatography that are quite popular basically in the field of in the field of chromatography, which is the gas chromatography as well as liquid chromatography. So if you see for gas chromatography, the mobile phase is basically gas, and for liquid, the mobile phase is basically liquid. So I'm going to, for this particular webinar is going to be focusing more on liquid chromatography. So under liquid chromatography, there are two types. We have the planar and also the column base. So again, HPLC is more towards columns. So we are going to focus on column chromatography. So when it comes to a column-based chromatography, there are two types that we need to look into. Okay, there are two types of phase we need to look into. One is the mobile phase and also the stationary phase. So mobile phase means it's the flowing phase. Okay, stationary is basically a very static base. So these are the two terms that is frequently used in HPLC. So each of these particular compound that moves within the mobile phase has a rate of migration, and it is actually determined by distribution coefficient, which is also the K. All right. So compound that the one that is commonly used is compound that are distributed in the flowing phase, which means usually in the mobile phase. These are the most common phase of column chromatography. Okay, so compound that are distributed in the flowing phase, basically they tend to move much more faster compared to the compound that is in the stationary phase, which actually moves slowly. So if you see in the figure bottom here, this is the column. Okay, so what you see inside is inside the column is actually the silica packed. So this is the stationary phase that doesn't move. So the mobile phase is the one that actually fills the spaces between the particles, and they go, they flow from one end to another. All right, which is latent perhaps, which you can actually collect for your other downstream works. Now let's look into some of the principle on the column. Okay, so column, few things that we need to remember when we are ought to purchase a column. Basically, we need to know what is the length, the diameter, as well as the pore size. Now, why this one is very important, because now the longer the length, okay, the diameter of the column, the longer the length, the column that we are going to purchase, it's going to give you a longer retention. But then the longer it goes, it tend to give you also a better separation. So in this case, if you have two compounds that is very much close together, then you can, use this particular length, which means you can play with the length, so you can get a longer column to get a better separation. So how about for diameter? Now, larger diameter means it requires higher flow rate. Basically, you need larger volume of solvents. So also this one also depends on what type of diameters that you want. We also have a range to distribute from Cosmosil. Now, when it comes to pore size, now when we increase the pore size, the surface area of the solute to bind basically decreases. So that is the reason why general analytical column will have about 120 size of, I mean, the pore size will be around that. Okay, so that would help in the locking the particular uh, solute that you actually want to analyze. So this is the column size that actually we distribute from Nakalai. So we tend to have few diameters as well as length. So again, all this depends on the type of compound that you would like to analyze. So another one more thing that is important in chromatography is actually the peaks. So basically when the solute, okay, pass through the column, peaks are actually generated, which are known as chromatogram peaks. So basically chromatogram peaks shows the concentration, how concentrated is certain compounds in that particular sample, and it is actually recorded in time frame. So basically, maybe in 5 seconds, 5 minutes of the flow, you tend to get a peak coming out. So maybe these are the peaks that you want to get them, and then perhaps you want to do them for your downstream analysis. So basically, the chromatography peaks are the important one for you to look to, whereby you can for you to obtain your targeted solute that you want to analyze. So another one more thing that is also very important is the eluents. So HPLC separation, it actually focuses on choosing the right mobile phase. Basically a solvent. So you need to know what is the suitable solvent for your sample. So what are some of the criteria that we need to look into? Number one is definitely the viscosity, because lower viscosity solvents has lower pressure. So when they have lower pressure, they are able to achieve the desired flow rate. So basically this flow rate are something that you will also optimize into. So when you have lower viscosity, you can actually achieve the flow rate that you want. And then you intend to have also the boiling point. So low boiling point facilitate in the solvent removal from the collected fraction. You also want to look into the detector compatibility, because you want to know whether they do not actually interfere. For example, like UV detection, if you have a UV based detector, then the solvent should have low absorbent rates, because when you have high absorbent rates, UV is also able to capture that particular absorbent as well. So it also gives you a false positive results as well. Yeah, and then rare fraction index detection also should not be near the samples. So these are the common solvents that actually most recommended. All right, so you can actually look into some of these solvents for your particular sample. Now, what is very common is basically methanol, okay, and then perhaps methanol and acetonitrile. So these two are quite commonly used as the mobile phase, and then you can elute to see how are the peaks formed. So basically, this is actually the workflow. So the first is definitely you tend to have a mobile phase reservoir. So basically, it is in either a glass bottle or conical phase. Okay, so to avoid clogging from insoluble compounds in the mobile phase, there is actually a suction filter attached to the inlet. Okay, then you also have a pump. So once this has this particular solution, so it moves into a mobile phase at a consistent flow rate or pressure. So basically there are two pumps that are required for gradient elution. You have injector. This is the injector as well. So injector is where you inject your sample using a micro syringe. So in certain equipment, we also have auto injectors. Okay, when you have a lot of samples, then maybe you want to consider them. So this is basically for automated sample injection. Of course, you have column. All right, HPLC definitely needs a column. So column, basically you have a packing material that is packed in a stainless steel or glass columns. Okay, so you put them and you fix them from one end to another end. Okay, and then you have a detector. So this detector, this is the detector. So this detector detects the compound eluted from the columns and sends to the recorder. So these are the recorder. What it does is it basically absorbs the signal and then it's able to draw chromatograms. So the retention time, peak area, theoretical plate numbers are all automatically calculated. Okay, so let's look into some Cosmosil based products. So for Cosmosil product, the basic is actually C18, which is the MS2. So this is the most general use column. So if you are looking into a column, so I would suggest to use a basic column and start up with C18. So if at all C18 doesn't give a choice, basically it gives you a poor peak shape or things, then perhaps you can choose other types of columns under C18 that narrows to your specific compounds. So if say you do not have enough separation, then perhaps you can look into more of specific columns that I will also discuss in the next slides. Okay. So for this particular column, basically we have two types. One is monomeric. Another one more is actually a polymeric. So it's actually based on the acid resistance and also residual. So monomeric tend to have low acid resistance, okay, while polymeric tend to have higher acid resistance. So they are still under the C18 base column. Okay, so the features is basically they tend to have strong acid resistant and good for acidic compound or peptides. Okay, and they are actually suitable for hydrophilic compounds, and they are very much stable in 100% aqueous condition. And if you are doing a basic compounds, very basic analysis compounds, then it is encouraged to try to kickstart with a C18 base column. Now, we also have a special column, or basically, like what I said, if you have a poor separation peak or peak shape, then perhaps then you can start using more special columns. So in the case of you do not have enough separation, sometimes you can use cholesterol base. All right, we have the rest of these that is very much suited for the compounds that you want to analyze. So for example, if you want to analyze with vitamin E, if the normal C18MS2 is not giving you a good peak, perhaps you want to look into the PFP. Of course, there is, you can ask what's the difference. So basically it is that there's a cost involved as well. All right, so basically the more specific the column goes, it gets more expensive. So you may want to try with a basic column first, and if it's not giving you a good results, then perhaps you can go into a more special or maybe more narrowed base column. So Cosmosil also has advantage whereby you can get a truly good web assistance from Cosmosil web page. So all you have to do is get into web page, Cosmosil web page, and you can see Cosmosil application. So under this particular Cosmosil application, you have what are you searching for? Do you want to search for what type of columns you need? So you just have to type in your sample name. All right, what kind of analysis do you want to do? And if you have some idea on the columns that you want to use and you want to see whether it's suitable, you can click. If not, it will suggest you suitable columns that you can use. In this particular data, you will also see, because there's an application base, so you can get to see the flow rate, the retention time, some of the graphs of samples that they have, which Cosmosil have used previously to analyze. So this particular web assistant from Cosmosil is truly convenient, and it's truly accurate. Now let's move on to some of the problems which commonly customer face. Yeah. So usually what happens is when they have, a very prominent problem is actually from peaks. They tend to have poor peak shape. For example, If you see on my left, you see a normal peak, which is sharp, but you also see like tailing peak, fronting peak, broad peak, spike, and also splitting. So all this actually has a cause, and there is also a solution. Now, if you have a tailing peak, perhaps you want to look into um, columns. Okay, there might be some voids in the column material. So it's about the time for you to replace to a new one. Okay, when if you have a fronting peak which has a tail, at the front here. All right, so it may be due to injection of large sample volume. So you may want to dissolve the sample in a mobile phase and you want to rerun them. And if you have broad peak, usually it is due to high molecular weight of certain samples. Okay, and then it could be also due to column deteriorate. So the best way to overcome this is to use wide pore size column. So if you see, it's more on the pore sizing. Okay, you want to reduce the volume of the sample that you're injecting, and also you may want to replace the column. When it comes to peak spike, especially when you have, which is very common when there is two samples inside. Okay, unknowingly you might prepare two samples, so they tend to have different separation properties for mobile phase and sample solvent. So solution is to literally either you can purchase the longer what we call these longer columns, so that can actually separate, or you need to change the mobile phase or the sample solvent. Now, peak splitting is because of different separation properties. All right, again, you need to dissolve these particular samples in a proper mobile phase or the sample solvent itself. Okay. Now, for resolution with C18 column, this is also quite common when you see that the peaks are very much closer to each other. So like what I've said, if it's much more closer, the best way is to look into a longer column. So how do you actually do this? Definitely you need to do a preliminary run to see how is it in C18, the normal column. So in the normal column, if it tends to give this, perhaps you may want to, play with some mobile phase, to make sure it separates. But if it doesn't, the next solution is to look into a longer column, because it tend to give you a good separation. Okay, and it gives you sharper peaks. Okay, and the next thing is, of course, change the mobile phase, because you know the sample chemistry well. So it's also good to check out in literature, and also perhaps you want to look into some suggestion that the web application from Cosmosil, what kind of samples and what are the mobile phase that you can use to dilute this particular sample. Also use packaging material that is non-hydrophobic interaction, so that is able to separate between sample and different columns. Clogged columns is also another common problem. So this could be due to the salt deposit, sample problem, or sample that is absorbed into the column, and you have hard time to actually remove it from the column. And also they tend to have a gradual increase in pressure. So all these particular things can actually cause clogging. So if you have salt deposit, so the recommendation would be to wash the column for 30 minutes under a half flow rate using 10% of organic solvent in water, or on the other hand, you can just 100% water under the same condition. If you have sample problem, okay, so sample should always be filtered. Okay, so it is discouraged to use sample as a raw, so it's good to be filtered to remove whatever debris are there. Okay, on the other hand, it is also good to use a guard column. Okay, guard column will always tend to protect the columns that you are using. Okay, on the other hand, you can also you need to wash, so definitely you need to connect it in the reverse direction and wash it for 30 minutes. So if sample is absorbed into the column, okay, because it can't flow through, but then it is truly absorbed and stuck, so wash it with a solvent that can literally dissolve samples. So you need to know what are the samples you're running, and perhaps what is the solution that can dissolve this particular sample. So if there is a gradual increase in pressure, it can be due to contamination of the column or column deteriorate over time. So perhaps it's about the time for you to replace the column. Another one more common problem is sample pre-treatment, how to actually pre-treat the sample so that it will not harm your column. Basically, it's to avoid column clogging and also sample precipitation in the column that you are using. So these are some of the sample pre-treatment that you may want to consider. One is a protein precipitation. All right, so basically what you can do is you precipitate and then you just take the organic, you remove the organic solvent layer and you want to analyze them. And then you can also use ultra base filtration. Okay, you can analyze the filter solution under a concentrated protein solution. Okay, so this is the filter. All right, basically you can get them from your distributors or those who sell this particular filter. Or you can also go into a solvent extraction method. So this is another one more procedure. So this particular procedure, you can actually get them from Cosmosil website itself. So you can read through and look through for this particular extraction method. Another one more that is very crucial is to use guard columns, like what I've explained earlier. So this guard column is basically, it's a connector that you connect before you even fix your analytical column. So it's like a column that guards this particular analytical column. So samples actually pass through these particular guard columns. So if there's any precipitation or anything like that, it will precipitate here. Only the solution that moves in. So this particular guard column, it's a protective column. Okay, so this particular column actually able to remove impurities or suspended solids from reaching the analytical column. So basically you want to use this particular column that you have purchased for a good long time. So if you're going to keep it for a long time, then it's very crucial that you use a guard column or guard cartridge. Okay, because there'll be always some unwanted materials unknowingly that tend to precipitate in the column. So some of the materials are like fatty acids, protein, and also particulates. So how do we actually maintain a column? So for daily care of column, especially for reverse phase column, so it is advised to use if your mobile phase contains buffer, salt, or acid, a wash step is required. Okay, so this is the wash solution that you can prepare. But on the other hand, what we have is we also have a cleaning solution from Nakalai. So this particular cleaning solution is to wash, remove buffers, salt. So you can also use methanol, okay, for your washing step as well. Okay, together with. So if you are using it for a short-term storage, okay, for about 1 week, you can tightly plug the column and store it at a cool place. But if it's for a long-term storage, you should replace the solvent with 70% methanol, and you flow for about 10 minutes, and then you can plug and store them in cool, dark place. So this is how you actually store them for a short-term and long-term storage, right? Now, there is also a storage solution for columns, especially when you're going to keep them for quite some time. Okay, in a longer storage. So we also have a storage solution. So it's basically quite direct. The procedure, after you wash a column, following the instruction, you have the cleaning solution. So you just have to run the storage solution into a column for about 15 minutes at the flow rate of 1 ml per minute. So once that is done, you can tightly plug the column and store them at dark room. So basically what we have from Nakalai is we have the cleaning solution as well as storage solution. So as for support, Nakalai Cosmosil gives a very detailed support online. Okay, they have catalog, not only catalog, but they also provide with technical notes. So this is the link. So you can actually go into, you can just type into Google Cosmosil Nakalai, and inside the page, when you scroll down, you will start seeing technical notes. So this technical notes consist of various FAQs, troubleshooting methods, and as well as basic knowledge on HPLC. So it is good that for any one of y'all who are new to HPLC to look into these particular technical notes. And they have catalog as well. You can browse through their catalogs for various columns that is available. Also, that is attached application data. So you may want to look into the flow through what kind of mobile phase they are using, what's the retention time they are getting some of these particular compounds. So you can look, all these particular application are found in the catalog as well. There are also application database. It contains more than 7,000 application using Cosmosil column, which I've explained earlier. So you just have to put in the type of samples, okay, that you want to analyze. If you have the idea, maybe the sample is from vitamins, you can click the vitamins, and then they can come up, the particular web page will come up with column suggestion for your reference. So that's all from me for today. So thank you so much for listening throughout this particular webinar.